All right, here's our bell word for the day. There's the answers for those so you can check your work. So exponents in parentheses. This is crucial because, like I said, that last part we was adding and subtracting exponents. Okay, depending on if the bases were being multiplied or divided. So on this one, we're going to see exponents with parentheses. And while we'll look at some expansion of this stuff, I think it's important that you know the rule. So the rule is if you have a base, I'll use x, although that could be a number, and that's fine. But if you take the two exponents like this, so this we use a and b again, and then it's got to be on the outside of the parentheses like this. That's b is an exponent. Then what you're going to do is you can take the same base, but the two exponents a and b, and you're going to multiply those two. All right. Now this is true no matter how many bases are on the inside of that parentheses, by the way. So it could be x and y, perhaps. Maybe the x has an exponent of a, and the y has an exponent of whatever, z, I guess. A different color there, z. And if this is all to the power of b, then that exponent b will apply to all the exponents on the inside of that parentheses. So this would be like a times b as an exponent for base x, and the exponent for base y would be taking that z and multiplying it by b as well. All right? So this can happen, and that's very nice, very pretty, but it can also happen in fractions with parentheses as well. So if you had two different bases, x and y like this, and they had different exponents, they could be the same, I guess, but if that has an exponent on the outside of the parentheses, you're going to keep the fraction with x and y as your bases. But once again, the exponents for both will be multiplied by b as well. Like this, okay? So that means that if you ever have parentheses, the exponent on the outside of the parentheses will apply, being multiplied, to any of the exponents on the inside, as long as you're only dealing with multiplication and division. Next year, you're going to learn if there's like addition or subtraction right here, then it will work very differently, but for now, we're just dealing with multiplication and division. I'll expand this first one with the base 3, actually. This one's not too bad. So if you were to expand this, first off, you take your 3 to the power of 3. And with this exponent of 2, that means you're going to need 2 of those, right? So that'd be 3 to the power of 3 right there. Which means you could just expand both sets. So that'd be 3 times 3 times 3, both sets of parentheses. And then another set of 3 times 3 times 3. And so you're seeing that all the bases are the same, being multiplied. So you're going to keep that base the same. And then you count how many? 1, 2, 3, 4, 5, 6 of them. 3 to the power of 6. But just like we discussed, since you got a set of parentheses with those exponents, you can take the two exponents, 3 and 2, and you could have just multiplied them to get that exponent of 6 right there. Okay? So let's look next at this this x to the power of 4 to the power of 10 to the power of 5 right here. This one in red. I'm not going to expand it though, just because that's a lot of stinking bases of x to write out. You'll see how many here in a second. But these exponents, right, of 4 right there in the middle parentheses, the 10 between the brackets, and then the 5 on the outside. Since they're all separated by brackets or parentheses right here, yeah, you just need to multiply those out. Yeah, and that's why I didn't want to write these out. 4 times 10 times 5, I get 200. And as much as you guys want me to write all 200 out, I am not going to. I'll do this one right here. Now, y to the power of 3 to the power of 2 to the power of 2. Now, this one expands quite expansive. Let me see if I can fit these. Yeah, I should be able to fit them in. So first off, I would start with this set of parentheses, and it shows 2 of whatever's on the inside. And this is the only time I'm going to be expanding these, so just be careful. That'd be y to the power of 3 to the power of 2, but again, I'd have 2 of those, right? Y to the power of 3 to the power of 2. Now for each of these, I need 2 of these y to the power of 3's, right? So I'm going to expand these. No, it's super fun. It's not, but that's y to the power of 3 times y to the power of 3. That's the first one, and then the second one, y to the power of 3 times y to the power of 3. Now you can see very quickly that this would become extraordinarily frustrating. Well, not frustrating, but tiresome if you had to do this all the time, which is why the rule is nice. That'd be y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 y's, right? There's 3, 6, 9, 12. And so my final answer would be y to the power of 12. Now, if you apply the rule that we saw, then all you would do is you take that base y, and then the exponents, since they're separated by parentheses, you would take all 3 of them in this case and just multiply them. 3 times 2 is 6, and 6 times 2 is 12. So that's how we get the 12 here at the end. The multiplication, let's look at this a little bit closer right here. Once you get to this point, whoops, this one right here, then you're looking at the same bases being multiplied. And so what would you do? You would just take these exponents and add them, right? 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Now that is also the same as 4 groups of 3, which if we go back to this part right here, you'd get 4 from the 2 times 2. This was now working this direction instead of what we had over here where we were working left to right. But 2 times 2 is 4, and that's why we get that 4 groups of 3. 4 times 3 is 12. And so it kind of goes back to the, I guess, the basic definition of addition, or multiplication rather, where it's just repeated addition, and you'd get repeated addition from this stuff right here. Let's do this one here at the bottom. 8 times b times c in parentheses to the power of 3. So I'm going to write all 3 of those out. Okay, so that's 8 times b times c in parentheses. That looks pretty. And then we're going to get another one right here. I could have copied that better, but it'll work. And then we got another one. 3 of them. There we go. 1, 2, 3. All right. Now, from this, I probably should give myself more space. But I got 3 different bases on this one. Okay, I've got A's, B's, and C's. And, well, how many of those A's, because this is all being multiplied, how many of those A's do we have? If I were to look at this, I'd have 1, 2, 3 A's, so that's a to the power of 3. How many B's are there? 1, 2, 3, so there's 3 of those. So that's b to the power of 3, and then C's 1, 2, 3 of those, so c to the power of 3. And again, this kind of goes back to the idea of, since we're multiplying the exponents, since they're separated by parentheses here, you'd have to remember that the a has an exponent of a phantom 1, the b has an exponent of a phantom 1, and the c has an exponent of a phantom 1. So we're just taking this 3 here and multiplying it by all 3 of the exponents. All right, and like I said before, even if you have more bases in the parentheses, the exponent on the outside of the parentheses will apply to all the exponents on the inside of the parentheses, and apply being multiplication. So let's do this one right here, the 4 times x times y to the power of 2, all to the power of 4. So I look at the 3 bases that I have, 4, x, and y. Now, the 4 has an exponent of 1, the x has an exponent of 1, and the y has an exponent of 2. But this 4 on the outside of the parentheses there needs to be multiplied by those exponents. So I will multiply them. And then in exponential form here in this last box, of course, you have the same bases, 4x and y. But they're new exponents after the multiplication. 4 has an exponent of 1 times 4, which is 4. Base x has an exponent of 1 times 4, which is 4. And base y has an exponent of 2 times 4, which is 8. All right, so that's what different bases being multiplied, and that's good stuff. Next up, let's do this one right here, the x times y over z all to the power of 4. That looks pretty good. And so even as a fraction, you've got your x, your y, and z right there. And those exponents right now, they're phantom ones on the inside of that box. So x to the power of 1, y to the power of 1, z to the power of 1. But this exponent of 4 being applied to those would be multiplication because of the parentheses. So yeah, you can just multiply 4 by those exponents, which when we fully simplify, here in this last column, make this a little bigger, we got bases x, y, and z, but new exponents of 1 times 4 is 4, 1 times 4 is 4, and 1 times 4 is 4. So all the exponents for these are 4, and I kind of separate those a little bit. I'll show the multiplication there. So now that we've seen that the rule works, I'm not going to worry about applying it or expanding these ones, okay? But I would look at, we'll start with this one right here. Okay, and again, I'm just going to be applying the rule, save us some time. So I'd say I got bases of 3, a, and b. Inside the parentheses, the 3 has an exponent of 2, the a has an exponent of 10, and the b has an exponent of 11. But this 4 exponent on the outside, it is separated with parentheses, so that means I will be multiplying the 4 by all of the exponents on the inside. So we got the 3 bases, 3, a, and b, but they're new exponents. For base 3, you have an exponent of 2 times 4, which is 8. For base a, I have an exponent of 10 times 4, which is 40. And then for base b, I have an exponent of 11 times 4, which is 44. There we go. And to expand this more in the fractional sense here, let's do this one here at the bottom. All right. So let's look at expanding that. No, we're not going to expand it. But I would take whatever's on the inside of the parentheses. So that's a to the power of 3 all over b to the power of 5. And since we have this exponent of 10 on the outside of the parentheses, it should be multiplied by all of the exponents on the inside of the parentheses, even if they're being divided of the bases. So that'd be exponent of a times a, which is 3 times 10. The exponent of b, which would now be 5 times 10. So now we need to simplify that. So it is still in fractional mode, or notation here. So we got a's and b's, a in the numerator, b in the denominator. But the new exponent for a, 3 times 10 is 30. And the new exponent for b, 5 times 10, which is 50. And that would be complete. So here's the rule, which I've shown already. They just use different letters being multiplied here. That's good. Or these ones. Once again, different letters. In fact, I put exponents in the bases in the parentheses. But again, you're just multiplying it by whatever the exponents are from the outside to the inside, the exponents. But once again, this is the third operation, basic operation of math that we go over with exponents. Addition of exponents, subtraction of exponents, that's what we did in that last lesson. And then in this lesson, we're looking at multiplication of exponents. We will not be looking at division of exponents in this class. All right, let's start with number 5 right here. So that's a to the power of 3 to the power of 5. And so I'm going to take my same base and these two exponents, 3 and 5. Since they're separated by these parentheses here, I'm going to multiply those out, the exponents. So the base stays the same, but the new exponent, 3 times 5, is 15. All right, b to the power of 7 to the power of 11. So again, I'm going to keep the base the same, the 7, but the two exponents, 7 and 11, we're going to multiply those because of the parentheses. So this ends up being b to the power, and you can see again why it's important to use, or nice to use these rules, because it's nice not to have to expand 77 of these b's out. And yes, it is possible to have many exponents, which we saw in one of those last examples. But since they're all being separated by parentheses, like this set of parentheses in red, so these three exponents, 5, 6, and 7. So the 5 and 6 are separated by parentheses, so that's going to be multiplication there. And the 6 and 7 are separated by parentheses, so that's also multiplication right there. And those brackets are considered parentheses. So if we wanted to multiply those out, you could use a calculator if you need to, but I believe you get 210. So right off the bat on number 6, I have a negative d base, and I'm just going to keep it in parentheses. But my exponents, 2, 10, and 3, since they're all being separated by parentheses, I'm just going to multiply those exponents. So I'm going to keep my base the same, negative d. And 2 times 10 is 20, times 3, 20 times 3 is 60. Now that's an even exponent, so I should be able to just make this positive. But right now we're just worried about operating with these exponents, not if the answer would be positive or negative yet. Although we will, right? Now on this next problem, I got a to the power of 1 and b to the power of 1. Again, it's being separated by this set of parentheses. So I'm going to need to multiply those phantom 1 exponents by that exponent on the outside, which is 5. And then we get base a and b still, same bases, but new exponents. For base a, 1 times 5 is 5. For base b, 1 times 5, that's 5. That's pretty good. All right, on this next one, I've got base a, and again, that would be an exponent of 1. That's on the inside the parentheses. And then base b, which is an exponent of 3. But again, since we got this exponent of 6 on the outside, it needs to be multiplied by all the exponents on the inside of the parentheses. So the bases do not change at this point, but the exponents will. For base a, 1 times 6 is 6. For base b, 3 times 6 is 18. And that would be our final answer for all three of these. All right, now before we start operating these exponents, it's important to know that all these have exponents right now. And one of the common mistakes, and I think I've said this before, but common mistake on this one is where students say 2 has an exponent of 2. It's right there. No, it does not. It has an exponent of a phantom 1. That's important to know. All right. So on this one, I have, I actually have some base x's in the parentheses. So I'm not going to work yet with the 2 exponent on the outside of the parentheses yet until I simplify the inside of this set of parentheses. And I can see I got these 2 x's in the numerator, these 2 x's in the denominator. That's just something divided by itself, so that's going to be a phantom 1. I crossed them out. Again, that doesn't mean they're canceled. They're just a phantom 1 right there. So I don't want to show it. I'm going to make it a phantom 1. So I'm going to keep 2 to the power of 1 in my numerator and y to the power of 3 in my denominator. Okay, but the x's to the power of 2, they became phantom 1s. And now I will apply that exponent of 2 on the outside of the parentheses. So I'm going to keep everything on the inside the same for now, and then operate with those exponents from this 2 on the outside. So that's 2 to the power of 1 times 2 in the numerator, and base y to the power of 3 times 2 in the denominator. So this is ending up going to be 2 to the power of, 1 times 2 is 2. And then base y in the denominator, but 3 times 2, the exponent, is 6. Now, just in case they do want this evaluated, which should be shown in the homework perhaps with like 1 box in the numerator, then you'd actually do 2 times 2 here to get 4. And I believe that's more how it wants, but it should specify if it wants a base with an exponent or if it just wants the number instead of the numeric base with the exponent. So I've said this before with these types of problems, and I'll say it again here, but it's nice just to focus on each individual base at a time. So for me, I would start with 12 divided by 2, which I know to be 6. And yes, I'm purposely putting that higher just in case we do have denominators. But let's look at now base x's. All right, I've got 6 in the numerator, 2 in the denominator. So that'd be 6 minus 2 if we were to apply the rule from the last lesson. So that'd be 6 times x to the power of 6 minus 2, which is 4. And then I got my base y's with exponents of 3 in the numerator, 2 in the denominator. So that'd be 3 minus 2 because we are dividing the bases. And so I end with y to the power of 3 minus 2, which is 1. I'll just make that a phantom one so it looks pretty. But that's it right there. And yeah, we didn't really need an exponent for the 6 either. All right, if I saw this one here, I would focus just on simplifying the inside of the parentheses, and I kind of suggest you do the same until you get a little bit more of a handle on this exponent business. Okay, so I just like I've said before, I would start with just the numbers. And yeah, again, I'm not really working with that exponent of 5 on the outside yet. But my numbers, I got 3 in the numerator, I got 2 in the numerator. Those are being multiplied. Again, you don't see all the multiplication, but it is. And we got a 4 in the denominator. 3 times 2 is 6, divided by 4. If I simplify this, I would get 3 over 2, just dividing the 6 and 4 by 2. So I'm going to write that in to the fraction right now, 3 over 2. All right, now I'll focus on my base a's. So again, just as a fraction, I'd have a to the power of 5 in the numerator, a to the power of 4 in the numerator, and then a to the power of 3 in the numerator. All right? So just from my numerator here, let's see if I can fit this in. I've got the same base being multiplied, so that'd be a to the power of 5 plus 4, all over a to the power of 3, which is going to be a to the power of 9, all over a to the power of 3. So to finish that off, kind of ran out of space there, but I got the same base. I'll do it below as much as I can. It's not really what I wanted. But I take my base a and then the 9 from the numerator and subtract the 3 exponent from the denominator, which would then be a to the power of 6. Now, since that's a positive exponent, I'm going to keep it in the numerator, a to the power of 6 right there. And next, I'm going to apply the multiplication of those exponents. So yeah, what do we got in this fraction? I got 3 over 2. Those exponents would be 1s each. And then I also have a to the power of 6 there. But I need to apply this 5, and by apply I mean multiply. So that'd be base 3 to the power of 1 times 5 times a to the power of 6 times 5. And then in the denominator, base 2 to the power of 1 times 5 as well. So what do we get from that? 3 to the power of 5 in the numerator. That'd be base a to the power of 6 times 5, which is 30. And then in the denominator, base 2 to the power of 1 times 5, which is 5. Now, again, you could evaluate this, but just to save us some time today, I'm going to keep it like this, all right? So you could evaluate 3 to the power of 5, 2 to the power of 5. 3 to the power of 5 is kind of big. But, again, it's nothing that your calculator won't do. So hopefully by now that we've finished the lesson, you feel comfortable at simplifying expressions with exponents and parentheses.